Hello everyone, I'm Sarvesh. Welcome back to the Data Science series. Today we are going to discuss what is regression modeling. Now, what is regression modeling? Regression modeling is a statistical technique used to understand relation between a dependent variable or predicted variable. The goal of this model is to predict relationship between dependent variable based on new data, and regression model can be linear, non-linear, or can be polynomial based on the nature of relationship. Now look at the types of regression models. Linear regression. In linear regression, when the chart is plotted, it gives us a singular line or line-like pattern. That's why it's called linear regression. There are multiple regression. Extend linear regression using multiple independent variables. In linear regression, there were one or more independent variables, but there are multiple, means two or more than two. Regression. Polynomial regression, as by the name polynomial, it is defined using a polynomial function equation or formula. Logistic regression, used for binary classification, meaning it is used for decisions like yes or no, male or female, right or wrong, like that. Now we will be discussing Python code of estimation model evaluation, which is another form of linear regression, and demonstrate stepwise regression using Python. We will not uh, get in depth with stepwise regression because it is tough. It is a topic of its own, but I will give you a basic idea. So let's see what is stepwise regression. Now, stepwise regression is a method of fitting, in which choice of predictive variable are carried by automatic procedure, meaning there is a step size. It involves adding or removing predictor based on the statistical significance. Means if 2 is closer to 0 and 5 is less closer to 0, the 2 will be chosen, or the predictor variable as. Now, let's see the code example. We have imported pandas and numpy libraries or modules as always, but we are including sklearn libraries, matrix, mean square error, and R2 square, and linear regression and train text split, which is used to split the database or dataset. Now here is a random sample data. Okay, and we have defined our data frame by random data. First, we are going to split the database using x and y variable, defining feature vision and feature 2 in x variable and target in y variable, and we are going to split based on xy and test size equals to 0.3. Now, train the linear regression model. We are going to train the regression model based on the previous split data set like xtrain and ytrain, which we obtained from here, and we are going to store the prediction value or predict the value of x text, which is a which is creating a linear regression model. Now evaluating the model means mean squared error, comparing between previous value of y and predicted value of y. Now an R2 score. R2 score can be positive and negative. As you can see in the output, we are printing MSE mean square error, which is 0.092242, and R squared, which is negative 0.03, which is acceptable under the range. I already told you It's similar to linear regression model, but it is on evolution phase. It is a linear regression model with evolution phase. Now stepwise regression. I have done manual method, but it is preferred to do automated method. Now same but stats model API. Now I have taken sample data and created a data frame, and we have split the database same as always. Now performing stepwise regression. This is a difficult function. Instead of this, we can directly call the function stepwise selection from the from the scalar library, and I would like to skip this step. But in short, there are two steps: forward step and backward step. If set is included or excluded, it will go forward or forward, and backward step, if it is already there, it will add to the data frame. Now use all coefficient except intercept, meaning on the plane level of x and y axis, the value which intercepts the value which instead of the value which intersects x and y axis, we will use all coefficient values except in the intercepts which are intersecting x and y axis on the diagram level, and return those values. Now let me tell you a little about code. This line p-values dot max. If first p-value, it means the which is almost intersecting the line is equals to max value of x or y axis or the plane of regression. We are going to see if first value is greater than threshold value, which we have taken zero point 0.1 to zero point 0.5. I'm sure it is there. We have taken default value of 0.01 and 0.05. If it is outside or below the inside the threshold, it will be ignored. Now included में in included dot remove worst feature. It will remove the worst feature which is intercepting the line or it is outside the threshold bound. Then it will remove the worst feature. Now after this will result in a stepwise selection of X train and Y train. We have called the result, which are random values. I have taken a dataset example of random values means it will be very difficult to print a regression or extract feature. As you can see, I am trying multiple times, but it is giving me an empty list. You can try this code too. I will recommend you to use automatic method of sklearn library. Thank you all. That's it for today. Thanks for watching.